Hello viewers, in today's class we are going to solve yet another important and conceptual problem from definite integrals involving greatest integer function and the absolute value function, right? So here we are given this problem, that is the integral of mod of x minus 1 divided by the greatest integer x plus 1 from 0 to 2 is equal to alpha over beta, right, where alpha and beta are some real numbers, and we have to find the value of alpha square plus beta square, right? So here what we have to do is we have to find the value of this integral, and once we find the value of this integral, we can compare it with alpha over beta, and then by comparison we can find out the value of alpha and beta, and consequently we can evaluate the value of this expression, that is alpha square plus beta square, right? And the special thing about this integral is that our integrand is a combination of the absolute value function and the greatest integer function, right? So let us first take this integral as I, and we can take this integral I as 0 to 2, and we have mod of x minus 1 over greatest integer function of x plus 1, right? So now here the integrand is a combination of mod function and the greatest integer function, right? So we have to take care of both these type of functions. So let us first take the absolute value function, right? Then we'll take the greatest integer function, right? So now let us apply the definition of absolute value function to this integral. So here we see that the lower limit is 0 and the upper limit is 2, right? And if we take this function, that is mod of x minus 1, then we see that the critical points can be obtained by solving x minus 1 is equal to 0. So we have x is equal to 1, right? And x is equal to 1, it lies between 0 and 1, right? So now we have 3 points here. 0 is the lower limit, 2 is the upper limit, and 1 is the point where we have to break this integral, right? So 1 is the breaking point where we have to split this integral I as a sum of two integrals, right? So the first integral is from 0 to 1 and the second one is from 1 to 2, right? So now see here we have two intervals. The first one is from 0 to 1, that is we have this interval that is 0 to 1, right? And the second interval is from 1 to 2, so we have 1 to 2, right? So this interval can also be written as x greater than or equal to 0 but less than 1, and this one can be written as x greater than 1 and less than or equal to 2, right? So here we have two intervals and we have to decide the sign of this absolute value function, right? So mod of x minus 1 is obviously negative of x minus 1 whenever x lies between 0 and 1, right? And mod of x minus 1 is positive x minus 1 whenever x lies between 1 and 2, right? So this is about the definition of mod of x minus 1, right? So now this integral I can be written as a sum of two integrals, that is I1 and I2, right? So I1 goes from 0 to 1, so here we have 0 to 1, and from 0 to 1 the mod function x minus 1 is negative x minus 1, and in the denominator we'll keep this greatest integer x plus 1 as such, right? So this is the first integral I1, right? And I2 is from 1 to 2, and here uh, when x lies between 1 to 2, mod of x minus 1 is positive x minus 1, right? And in the denominator we have the greatest integer x plus 1, right? So now we have these two integrals, right? So in the first step we have uh, explained, or we have taken the definition of mod function, and in the second step we have to take care of this greatest integer function, right? So let us first take this integral I1, and here we see that x varies from 0 to x equal to 1, that is x lies between 0 and 1. So if we add 1 throughout, we are adding 1 throughout because we wish to find x plus 1. So if we add throughout 1, we get 0 plus 1, and here we have x plus 1, and here we have 1 plus 1. So we have 1 and here x plus 1, and this is 2, right? So we see that when x lies between 0 and 1, x plus 1 lies between 1 and 2, right? So therefore by definition of greatest integer function, the greatest integer x plus 1 is equal to 1, right? Now if we take the second integral I2, then we see that x varies from x is equal to 1 to x is equal to 2, right? So here we have x greater than or equal to 1, and here we have 2, and again see here we wish to find the greatest integer x plus 1, so we'll add 1 throughout, so we have 1 plus 1, and here we have x plus 1, and here we have 2 plus 1, right? So we have added 1 throughout this inequality, so now we have 2, and here x plus 1, and here we have 2 plus 1, 3, right? So when x plus 1 lies between 2 and 3, then by the definition of greatest integer function, the value of greatest integer x plus 1 is 2, right? So now we can rewrite these two integrals as integral from 0 to 1. From 0 to 1, here we have 1 minus x, and for greatest integer x plus 1 we can write 1, right? Because when x lies between 0 and 1, that is 0 and 1, then the value of greatest integer x plus 1 is equal to 1, right? And the second integral is from 1 to 2, and here we have x minus 1, and the value of greatest integer x plus 1 when x lies between 1 and 2 is 2, right? So here we have 2 and dx, right? So now we have these two simple integrals, and this can also be written as 0 to 1 minus x dx, and we have 1 to 2, and we can take half outside, so we have x minus 1 dx, right? Now we can calculate these two integrals. So now I is equal to here we have the integral of 1 minus x as x minus x square over 2, and the limits are from 0 to 1, right? And here we have half, and the integral of x minus 1 is x square over 2 minus x, and the limits of integration are from 1 to 2, right? So now we can simply substitute the limits and we'll take the difference. So the first expression is 1 minus 1 over 2, because 1 minus 1 square is 1, so 1 over 2, and minus 0, because here we have 0, here we have 0, so we can write it as 0 minus 0, and here we have half, and when x is 2 we have 2 square 4, 4 over 2 is 2, and minus 2, and then we have minus, and here x is 1, so we have 1 square over 2, that is half, minus 1, right? So now we can simplify it. 1 minus half is half, and here we have half, and this is 2 minus 2 is 0, minus, and half minus 1 is minus half, right? So now this is half plus half, and minus minus plus, so we have half, and we have half plus 1 over 4, and this is 4 taking LCM, we have 2 plus 1, that is 3 over 4, right? So viewers, the value of this integral I is 3 over 4, right? And we are already given that the value of this integral is alpha over beta, so 3 over 4 can be written as equal to alpha over beta, right? And if we compare, we get alpha is equal to 3 and beta is equal to 4, and we have to find the value of alpha square plus beta square. So alpha square plus beta square is equal to 3 square plus 4 square, and 3 square is 9, and 4 square is 16. So the value of alpha square plus beta square is 9 plus 16, that is 25, right? So viewers, this is how we solve this important and conceptual problem, right? And the special thing about this integral is that this integral, it consists of two important functions in mathematics, that is the absolute value function and the greatest integer function.